gesture action mapping for deformation-based 100 landscape mode interaction with flexible smartphone-sized devices. My name is Pranjal Pratim Bora and my co-authors are Mr. Jamie Seth and our supervisor Dr. Keyur Sarathia. We are from Embedded Interaction Lab, Department of Design, IIT Guwahati. First, deformation-based gestures. On a deformable device, user can provide input by changing the form factor of the device. For example, here the user is providing input by bending the top right corner of the device. Then the descriptors of deformation gesture. Two natural descriptors of deformation gesture are the location and direction of bend. Here the location can be the corners of the device, the sides of the device, horizontal or vertical axis of the device, and the directions could be bending towards downward, that is away from the user, and bending towards upward, that is towards the user. In this study, we wanted to understand how users map deformation gestures to the commonly used actions of one-handed landscape mode interaction. 30 university students participated in the study between the age group of 19 to 28 years. All the participants were right-handed except one participant, and they all have 5 years of experience using smartphone, including one-handed landscape mode uses. We selected 4 gestures from the literature, that is natural and intuitive deformation gestures for one-handed landscape mode interaction. The first gesture is left side bend upward, and the second gesture is top right corner bend upward. Third gesture is horizontal bend upward, and the fourth gesture is horizontal fold upward. We selected two applications, the video player application and the camera application. For the video player application, we selected 7 actions, and for the camera application, we selected 5 actions. Then the prototype used for the study is of dimension 154 mm by 74 mm by 8 mm. The mock-up prototype was developed using 1.5 mm thick PVC sheet sandwiched between two 3 mm thick EVA foam sheets, and we used projected display to provide visual feedback to the user. Based on our understanding from the literature and prior experience with flexible smartphone-sized prototypes, we hypothesized that the top right corner bend upward gesture is the easiest to perform in one-handed landscape mode interaction with right hand. Again, the top right corner is the most appropriate and preferred gesture for mapping with multiple actions that are associated with distinct spatial directions. The appropriateness scores of the preferred mappings are positively correlated with the ease of performing the mapped gestures. We asked the participants to rate appropriateness score for each mapping on a 5-point Likert scale. They also proposed the preferred mapping. At the end, participants rated the ease of performing the gestures on a 5-point Likert scale. As a result, we found that the top right corner bend upward gesture is the most easy to perform among the 4. We also found that it is the most appropriate gesture and the majority preferred mapping for the actions like rewind video, volume decrease, exit shutter, zoom in, and zoom out. This indicates that we accept hypothesis 1 and 2. However, we do not have enough evidence to accept the hypothesis 3. Since only ease of performing the gesture does not explain how users map these gestures to the actions, we asked the participants to provide their verbal feedback about why they are mapping these gestures and how they are rating the appropriateness scores. From this subjective data, we found the effect of perceived directional similarity on gesture action mapping. For example, if we have a rewind video function which tends to move towards left, and if we have a gesture top right corner bend upward, which presents a better similarity between the directional cue of the gesture and the direction associated with the action. We also found that some of the gestures provide multiple distinct directional cues which can be related to multiple actions. For example, bending top right corner has one component along negative x-axis, has another component along negative y-axis. Since it is an upward bend gesture, users can also relate the direction of bend to the z-axis. We found that gestures that can be related to multiple directional cues can be related to multiple actions. We also found that the required effort and the size of deformation also influences user decision. Finally, the tremble and occlusion during deformation and the user's prior experience also influence the gesture action mapping. For example, using band gestures to take a picture. For example, one participant mentioned that I cannot use the top right band gesture or any band gesture to take a picture. When the user performs the band gesture, it usually leads to trembling, which can result in shaky image. However, to address this issue, user can use hold time based triggering strategy. Again, occlusion during deformation is another factor that influences gesture action mapping. In addition to this, the prior experience with touch-based devices, for example, the capture image or video button at the center of the right side, motivated some of the participants to perform the horizontal band gesture, considering that they are triggering that button using band gesture. At the end, the takeaways are: the top right corner band upward gesture is the easiest to perform. The corners and sides can be mapped to multiple actions. Besides ease of performing the gesture, appropriate and preferred mapping is influenced by the perceived directional similarity, the required effort, and the size of deformation, along with the tremble and occlusion during deformation. We also observed that when the user has to select one of the gestures out of multiple appropriate gestures, users often resolve this based on ease of performing the gestures. For more details on this project, kindly go through our paper and visit our website for other related projects. Thank you all.